For decades, astronomers believed the large-scale structure of the universe was mostly understood, a cosmic web of galaxies, dark matter, and vast empty voids stretching across unimaginable distances. But everything changed when the James Webb Space Telescope pointed toward a region that was supposed to be completely ordinary. Instead of finding the expected emptiness, Webb detected a hidden structure woven beneath the cosmic web itself, a perfectly aligned anomaly stretching for hundreds of millions of light years. Not a galaxy cluster, not a void, not anything familiar, something else. Something that should not exist according to the physics we rely on to understand the universe. What Webb uncovered wasn't a cloud of gas or a cluster of stars. It was a massive, linear formation buried inside a region we assumed was empty. At first, scientists dismissed it as a sensor artifact, a glitch caused by Webb's extreme sensitivity. But repeated scans showed the same thing. A long, thread-like structure producing faint, rhythmic distortions in the surrounding light. It bent light in a way that suggested enormous gravitational influence, yet emitted no visible matter. No galaxies, no dust, no radiation. A structure with weight, but without form. That alone was shocking. But then came the real mystery. The distortions weren't random. They formed a repeating pattern, almost like pulses, regular, predictable, and synchronized across impossible distances. In normal cosmology, nothing behaves like that. Gravitational lensing from dark matter is messy, chaotic, unpredictable. But here, the pattern was too clean, too organized. Something was shaping spacetime with a precision that demanded explanation. Researchers ran simulations, compared data with lensing maps from Hubble, Gaia, and ground-based telescopes. None of them matched what Webb recorded. Something lurked beneath the cosmic web, influencing matter, yet invisible to every instrument we've ever used, except Webb. And this was only the beginning. When astronomers reprocessed the data using Webb's deep infrared spectroscopy, they discovered another clue, a faint thermal signature, warmer than the surrounding emptiness. Cosmic voids are cold, silent, and almost perfectly uniform. But this region wasn't. The hidden structure produced heat, just enough to be detectable, but too little to come from stars or gas. Heat without matter, gravity without mass, order without origin. And now scientists face a disturbing question. Are we looking at a fossil of the early universe, a scar left behind from the Big Bang, or the first evidence of a new kind of cosmic phenomenon unfolding right now?
The more scientists studied Webb's anomaly, the stranger it became. When they reconstructed a 3D model from Webb's lensing data, they expected an uneven shape, like most dark matter distributions. Instead, what emerged was a perfectly straight line, almost impossibly straight, running through the cosmic fabric for nearly 500 million light-years. Nature rarely produces straight lines on such cosmic scales. Even galaxy filaments curve and twist. But this structure didn't bend, it didn't taper, it didn't branch. It was as if someone had drawn a single stroke across the universe and left it there, untouched for billions of years. And yet, it wasn't static. Webb detected microscopic shifts, tiny oscillations traveling along the length of the structure, compressing and expanding like waves along a tensioned wire. These oscillations weren't random. They repeated every 190 million years in a pattern no natural gravitational system should follow. Some researchers proposed that the structure might be a primitive cosmic string, a theorized one-dimensional defect formed in the first fractions of a second after the Big Bang. Cosmic strings are predicted to be extremely dense, extremely thin, and capable of warping spacetime dramatically. But no one has ever found proof they exist. If this structure was a cosmic string, it would be the first direct evidence of physics operating at energies far beyond anything we can test on Earth. Others disagreed. The structure didn't behave exactly like a cosmic string should. It produced heat, which strings shouldn't. It oscillated, which models don't predict. And strangest of all, its gravitational influence didn't match the expected profile of early universe defects. Instead, the structure seemed to interact with the cosmic web around it. Galaxies near the anomaly had slight shifts in velocity, as if being tugged but not uniformly. The effect depended on where they were positioned relative to the invisible line. It was almost as if the structure were communicating with its surroundings, influencing matter at vast distances through a mechanism we don't recognize. To make matters even more puzzling, Webb identified small fractures along the structure. These fractures behaved like stress points, places where the oscillations intensified briefly before stabilizing. And every fracture emitted a burst of high-energy particles. Not many, not enough to light up the region, but just enough to be measurable. These bursts shouldn't exist. They don't fit any known astrophysical process. And yet, they occur at regular intervals along the structure, as if following an underlying blueprint.
When scientists expanded Webb's search area, they discovered something even more unsettling. The structure wasn't isolated. Around it, the surrounding cosmic web showed subtle but undeniable patterns, as if galaxies had formed differently near the anomaly. Their distribution bent slightly toward the hidden line, almost imperceptibly, but consistently across millions of light years. In other words, the structure had been influencing galaxy formation for billions of years without our knowledge. That single fact forced astronomers to reconsider everything they thought they understood about the universe's early evolution. If this anomaly predated galaxy formation, it means the universe carries scars, cosmic imprints, from an era before matter existed. But here's the strangest part. The structure isn't relic-like. It behaves as if it's still active. Webb recorded slow twisting motion along its length, a torque so faint it would take tens of millions of years to become noticeable, but it's there. This twisting motion generates ripples that propagate outward, reshaping the surrounding gravitational field in measurable ways. These ripples correspond exactly with the rhythmic oscillations detected earlier. That correlation was the key. It suggested the structure might not be a leftover from the Big Bang, but part of a larger, ongoing process. Some theorists proposed an exotic idea, that the anomaly could be a domain wall between different vacuum states of the universe, a boundary separating regions with slightly different fundamental properties. If true, it would mean our universe isn't uniform at the deepest level, that beneath the familiar physics lies a patchwork of different vacuum conditions stitched together by invisible seams. And Webb may have found one of those seams. Other researchers suggested a more radical interpretation, that the structure could be a stretched-out wormhole, an elongated tunnel of space-time pulled so thin by cosmic expansion that it no longer behaves like a traversable portal. Instead, it remains as a long, partially collapsed corridor, still carrying energy from the early universe. But even this idea doesn't explain the heat, or the fractures, or the periodic bursts. Something inside the structure is active. Something is transferring energy. Something is vibrating, pulsing, interacting with reality in ways no known cosmic object does. And just when scientists thought the mystery couldn't deepen further, Webb detected a second structure, not parallel, but angled, intersecting the first.
This second structure changed everything. It suggested the universe might contain not one, but multiple hidden formations, an entire network of invisible lines threading through the cosmos. And the intersection point, where the two structures crossed, revealed the most dramatic distortion yet. Light passing through that region twisted violently, bending in multiple directions at once, as if space-time were folded into a knot. But the knot didn't behave like a black hole. It wasn't a tear, and it didn't collapse matter. Instead, it acted like a stabilizing joint, reducing the oscillations along both structures,
a space-time anchor, something that shouldn't exist in any standard cosmological model. When Webb focused on the intersection, it found the strongest thermal signature of all, heat radiating from a region with no matter whatsoever. It was the signature of energy being exchanged directly through space-time curvature, a process that, until now, has only existed in mathematical theory. This discovery has forced scientists to ask questions once considered too speculative for serious research. Are we witnessing the skeleton of the universe, a hidden framework buried beneath the cosmic web, guiding the formation of galaxies and shaping the evolution of spacetime? Or are these structures evidence of ancient physics, traces of the universe before the universe, formed during the earliest instance after the Big Bang and preserved for over 13 billion years? Some believe we may be seeing the first proof that spacetime is not smooth, but built on a deeper architecture, a lattice of defects, scars, and filaments left behind from primordial transitions. Others argue we are witnessing something even stranger, a system still evolving, still moving, still reshaping itself, a cosmic phenomenon in progress. And if that's true, the universe we observe today might not be the final version of reality. It might still be changing at the deepest level, slowly, silently, invisibly, beneath the galaxies and stars. The James Webb Space Telescope was built to look back in time, but with this discovery, it may have revealed something different, not the past, but the hidden machinery of the present, a structure no one predicted, a mystery no one can yet explain, and perhaps the first glimpse of a cosmic architecture that will redefine everything we think we know about the universe.